All right, algebra, we are going to be talking about factoring specific types of binomials, and it's when they are perfect squares. So I'm going to go ahead and blow through this first part right here. I'm actually going to fill out this chart, but I'm going to push pause, and then it's going to come back and it's going to be filled out. So hold on one second. Okay, I filled most of it out. It was too messy filling out the other bigger numbers. But what you can see essentially is this is just perfect squares. 1 times 1 is 1. You take the square root, though, it introduces a plus or minus. That means if I times -1 times -1, it'll be a positive 1. Let's take 16, for example. So if I do 4 times 4, that's equal to 16. But if I take the square root of 16, it introduces the answer as being plus or minus 4. All that means is if I take -4 and multiply by -4, it'll also give me a positive 16. So I left the right-hand side a little incomplete, but just understand that you need to know these, basically 1 through 12, your square roots. This will help a lot. So I'm going to go ahead and talk about how to do these problems, basically. I'm going to resize this, so look out for the big boom in your face, and then I'm going to come down to here. This is going to be very quick. So this is something that is very easy to remember. When you have the difference of squares, it essentially is like this. If you have a squared minus b squared, this can factor out to a plus b times a minus b. So what does that look like? Check out this right here. In this first example, you can see that my a squared is literally a squared, and my second one, my b squared, is actually equal to 1. So watch how I can do this quickly. I can do a plus 1 times a minus 1, and we have ourselves our factors. So this first part is a perfect square, and actually, believe it or not, 1 is a perfect square. So if you're lost, don't worry. We're going to do the next example together right now. Check it out. Number 2, I have a perfect square, which is just b squared minus 4. The square root of 4 is 2. So this is my answer. It's going to be b plus 2 and b minus 2. And notice, this only works if right here, if you have right here, is a minus sign. So if that is a minus sign, then that's going to work. Otherwise, it doesn't really work. So that's that. What is the pattern? Yeah, clearly, you end up with two things. You end up with a plus and a minus, and you just take the square root of the 4. You take the square root of b, which in this case, the square root of b squared is just b, meaning b times b is b squared. And that's it. So I'm not going to write down the pattern. I'm going to go ahead and fill these out as well too. X squared minus 9. X squared is a perfect square. 9 is a perfect square. So this should be pretty quick at this point. X plus 3. And then x minus 3. I have d minus 4 over here, and then d plus 4. There was some questions that I could, number 5 is fun. I'll talk about that in a second. 3h plus 1 times 3h minus 1. So notice you have to do the perfect square of everything. The square root of 9 is 3. The square root of h squared is h. And that's a minus right there. Number 6 is fun too. 5x minus 8 times 5x plus 8. So some of the some of the assignments, why am I saying outfits? Some of the assignments y'all had, you couldn't really solve the last part of it without this little bit, but now you have it. It does not matter if you write the plus or minus part first. You'll notice in some of these examples I'm writing the plus sign first, and then the other ones I'm writing the minus sign first. It does not matter so long as you get the right terms. The square root of 16 here is 4. Square root of x squared is x. Square root of 49 is 7. Square root of y squared is y. And that's basically it. This is a fun one, I think. Little easy day. Square root of 36 is 6. Square root of y squared is y. And then just copy that over. And take a moment to look at these. This should be pretty straightforward at this point. I'm going to go to the next page. Okay, I'll go ahead and finish 9 and 10. We have right here 2a plus 9b. And then we end up with 2a minus 9b. Number 10 is c minus 10d times c plus 10d. Again, don't really care if you do the minus or the plus first. It's up to you. That's that. Now, there is another step as well, too, I want you to worry about. Some of these problems we do require a first factoring out of a GCF. So this is just a review real quick. X squared plus 15x. You can actually factor out an x, and you end up with x plus 15. And yes, that's review, but just make sure you understand that. Check out this last part right here. And this is all I'm going to do. I'm going to stop here. I can factor out an even number on this one. That's great. That's the bell. I can factor out an even number on this one, and it's pretty simple. Hold up. I'm going to take out a 2 in this and check out what my answer is. Plus 20. So I know I'm just blazing through this pretty quickly. This is essentially just one of those reminders that some of these problems are a little more complicated. That's all I'm going to do for the notes. There is an assignment today, and I will be doing this lecture live as well.